Firstly, my name is Dan Stefanica. I am the head of projects here at EHPA. You probably know me if we deal in projects together, or if you have participated in EHPA events before. The session today will take, oh, sorry about that, a bit of a misclick there. So the session today will take 1.5 hours. And it will be a short introduction from me that hopefully you'll find quite interesting, because it's about what you can participate in. Then a short introduction of the speakers, so we know who's online today. Then a bit about each person's business model, each person's work. So we have Andrea, we have David, we have Jonathan, we have Dan, we have Mark, and we have Thomas. Each have quite an interesting set of work and something that for sure you'll find useful. Then there's a little bit of a Q&A where you can ask the questions that you want to ask, as well as some questions that I can see from their presentations that I would like to ask. However, there is a chat box in Zoom. So if at any time you would like to ask something to the panelists, they're already aware that some of the questions will appear there. So feel free to pose the questions that you might have at any time. If we do not get through all your questions, you'll see that each of the speakers' presentations has a way of getting in touch with them. And if not, just ask me, and I'm sure they will be glad to answer your question afterwards. As usual, in a few days' time, I would say in about 2 days, you will receive the recording of this session. It will be uploaded to our EHPA YouTube. So even if you lose the email with the recording where it is, we can always find it on our YouTube channel, along with all the other webinars we did lately. And you'll also receive the presentations. So all the presentations that you see will be given to you. So if you see a slide that has a link, don't worry about it, because you'll be able to press that link. So a little bit about this project that we have called the Renewable Heating and Cooling Platform. This is a European technology and innovation platform. You can use the QR code with your phone to take you directly to the website. It's basically a very interesting project that deals a lot with policy, and it's basically a lot of very important researchers, very important stakeholders come together from several technology associations. So us heat pumps, but there's also solar thermal, district heating and cooling. And we try to have a vision towards 2050. We try to talk about how we can mass deploy our technology, as well as we try to actually steer the Commission and the policymakers towards the sectors and towards the investments that we think are necessary. But for the purpose of this webinar, because we're dealing more with business models, I would like to point the possibility that this project, and in particular its website, has a database of renewable heating and cooling projects that you, if you have a project, can also submit. The database looks like what hopefully is on your screen now. And we already have about 130 projects. We will continue this database for the coming years, I would say. The advantage of it is that everyone can submit their project, and it's quite user-friendly. So it has a lot of filters that you can easily put so that you find out the list of just the projects that you need. There are the contact details of the people responsible for them, either coordinators or partners. You have the link to their website. So you have basically all the information in a condensed manner, but also very easy to find. So we strongly encourage you that if you have such a project and you go to the database and it's not already there, to submit it, and we will make sure that it's there if it's suitable, of course. Then just a little bit more about the project. There are a lot of opportunities that are open if you are part of this platform. So membership is free, but you basically get a lot of advantages of participating in the events that are made by the platform, of having a say in the priorities for research, in the deliverables that we're making, to basically networking with a lot of the other experts that are there. And there are a lot of experts in a lot of horizontal working groups and a lot of technology panels. So there's quite a lot of opportunities for this project. With that being said, let us begin a little bit our presentations. And it is my pleasure to introduce the speakers that we have today. So firstly, Andrea Barbon, he's the sales application manager for large heat pumps at Turboden, helping customers to reduce greenhouse emissions for both the district heating sector and energy-intensive industrial processes. He's supporting potential customers in the selection and purchase of LHP for each project. He holds a master's degree in energy engineering and the energy manager certificate. So welcome, Andrea. Very happy for you to be here today.
Hello, everybody. I'm glad to be here. Thank you, Dan, for this opportunity. So see you later in a while.
Thank you. Next, David Mugunan, a staple participant in our events and a very helpful collaborator with us. And hopefully you will also get in touch with him, because he's working on a very interesting project, and also the company that he's working on has a lot of interesting and diverse projects. He is a manager at Alouan, and he's dealing with the Sun People project. He's coordinating it, a project financed by the Interreg France Channel England program. He has a PhD in biomedical engineering. He has more than 15 years of experience in applied research and development. So welcome, David. Very happy to have you here in this fine morning.
Thanks.
Next is Jonathan Solomon. He works for the Plymouth City Council as a low carbon city officer, including in the establishment of Plymouth Energy Community, delivering solar PV for over 38 schools and building the solar farm community, as well as development of planning policies in relation to energy and carbon reduction, negotiation on planning applications, and involvement on the district energy projects, exploring heat pumps and solar, while also developing net zero carbon community housing proposals. Welcome, Jonathan. Very happy to have you here this morning.
Thank you, Dan. Good morning, everyone.
Next speaker is Dan Turner. He is the renewables lead at the Plymouth Energy Community. He has a background in developing renewable energy and low carbon infrastructure projects in the UK and US. He leads on PEC's development of new energy projects, building on their 6 megawatt solar portfolio. Dan has a master's in sustainable development from Exeter University. Welcome, Dan. Happy to have you this morning.
Good morning, Dan. Hi, everyone. Thank you very much for having me.
Our next speaker is Thomas Walter. He's the managing director at Easy Smart Grid in Germany. His professional career focused on digitalization with roles in research and development, product management, strategy, business development, and general management in medium to large industrial settings. Since 2011, he works in energy, founding Easy Smart Grid in 2014, voted top 3 smart energy startups by AIT Digital in 2014. The company's goal is to develop and provide smart technology for efficient, renewable dominated energy systems. He studied electrical engineering at the universities of Karlsruhe, I'm sorry if I mispronounced that, and Essex in Great Britain, and holds a PhD in industrial sensing from RWTH Aachen. Welcome, Thomas.
Good morning, everybody. So the university was Karlsruhe, and that's where I'm attending this conference from. Thank you.
Thank you so much. I have to say that sometimes I do this, that I'm not sure how to pronounce a word. So be patient and merciful with me, please. And lastly, Mark Howard. He has an engineering background and over a decade of experience in the low carbon sector, which he brings to his role of project manager at Regen, where he specialized in heat and the built environment. Whilst at Regen, Mark has authored 2 recent papers covering the decarbonization of heat in the UK, worked in supply chain development for whole house retrofit, and produced a range of technical future predictions of heat scenario models. In previous roles, he has worked in industry to design and deliver low carbon heating solutions, developed carbon offset projects, and led on carbon auditing and reduction policies for small to medium enterprises. Welcome, Mark. Very happy to have you this morning.
Great, thanks very much, Dan. Morning, everybody.
And with that being said, I give the floor to Andrea, that will talk about the wonderful work that Turboden is doing in our sector. And hopefully he also has the control of the mouse because he'll be changing the slides. Andrea, the floor and microphone is yours.
Thank you, Dan. Thank you. I will start saying a bit of what I'm going to present you. So a short presentation showing the benefit of heat pumps compared with the fossil fuel-based technologies, not only for a benefit in terms of carbon footprint reduction, but also for from an operative point of view. Okay. So first of all, a short introduction about Turboden. Turboden is active since 1980, and it is an Italian film company and global leader in the manufacturing of organic ranking cycle systems that are, let's say, basically turbines for generation of electricity and heat in a cogenerative way, if needed. We are part of Mitsubishi Heavy Industries since 2013. And since 3 years, we introduced 2 new products in our portfolio, in particular the large heat pumps and the gas expanders. The heat pumps in particular are very similar to the organic ranking cycle system, basically the same thermodynamic cycle, but in inversal mode. So instead of producing electricity, heat pump is absorbing electricity and generating heat at high temperature as a benefit of the system, with all of the components of the cycle that shares a lot of common features with organic ranking cycle systems. So I will start with the global trends, saying what is coming from the market and which are the main trends there. So the first one is the fossil fuel cost that is increasing. It is a target sector according with the Paris Agreement, saying that there will be an important cut of fossil fuels usage within 30 years and then in the future. The second one is the carbon cost increasing. That is also connected to the first point, saying that carbon price is increasing year per year. As of today, the carbon cost is roughly between 40 and 50 euro per ton of CO2, and the forecast for the futures will lead to up to 100 and then up to 150 tons euro per tons of CO2. And then the electricity price decreasing. That is a global trend due to the increased share of renewables within the energy mix. It means that the electricity price is going to be cheaper and cheaper in the following years. And this will be one of the advantages when talking about heat pumps that I will present later. So first thing to say that this is a specific example of application with concrete numbers in order to let you better understand my point of view and Turboden point of view about that. For sure, then it is possible to adapt and to adjust the example depending on the specific case. In this case, I'm comparing fossil fuels technologies with heat pumps, where the final user needs 90 degrees C and approximately 10 megawatt-hour of thermal energy. I will start with a comparison in terms of carbon footprint, saying that we did an hypothesis about the typical boiler efficiencies, that is 90%. So it is very typical for fossil fuel-based boiler, saying that the energy input to the boiler will be 11 megawatt-hour with a 1 megawatt-hour loss, thermal loss. And in order to generate that 11 megawatt-hour of thermal energy to feed the boiler, depending on the specific fuel you are using, the carbon emission will be in a range of 3.75 for coal, 3 for ton of CO2 for the fuel oil, 2.7 for gasoline, and 2.15 for the natural gas. So that it means that the emission is strongly dependent on the type of fuel you are using, but here is the range for the typical fuels that are used as of today. Going with the heat pumps, it depends a lot on the COP, so the coefficient of performance that it is possible to achieve. Said that the COP is defined as the thermal power output of the heat pump, so that 10 megawatt-hour thermal ratio with the electricity consumption. Here I put it 1 to 2 megawatts per hour, saying that this specific example is based on industrial heat recovery. The COP formula already said can also be presented in a different way, said that in order to have good COPs, it is important to limit the delta T between the heat user and the heat source. The heat source could be from industry or from the environment. And here I presented a couple of alternatives. In case the heat source is from industry, the typical temperature of that heat source is between 50 and 70 degrees. Then for sure, it depends a lot on the specific case, but these are the typical temperature levels. And the typical heat carrier is wastewater or some exhaust gas within the industry. In case of environment heat source, it could be groundwater, seawater, or river water in the range of 10 to 50 degrees C, depending on the heat source specifically. And here in the right side, I show the potential and typical COP achievable in case of industrial heat source or heat source from the environment. So for the industrial heat source with a temperature of 50 to 70 degrees, the typical COP achievable is in the range between 5 and 10, while in case the heat source is from the environment, the typical COP is much lower, 2.5 to 5, saying that to produce the same amount of energy output, it is needed to consume more electricity. So in principle, where the heat source is at a higher temperature level, it is much more convenient to have an heat pump in place. So here the comparison is in terms of CO2. So I'm just saying that electricity, so that range with a COP 5 to 10, saying that the consumption is 1 to 2 megawatt-hour electric, that electricity could be buy from grid or from renewables. In case it is buy from grid, the CO2 emission to produce that electricity is strongly related to the specific country energy mix. I will say that we took some data from EEA about that, showing the specific CO2 emission per megawatt per hour country per country in the European countries. And here I took the average value of 295 kilograms of CO2 per megawatt per hour. This is the European average value, but as you can see here in the right side chart, it is strongly variable depending on the specific country. Where it is very low, it means that there are a lot of renewables in place, lowering that emission. So taking the average value, the carbon footprint for that 10 megawatt hour thermal power will be in the range of 0.3, 0.6 ton per CO2. In case the electricity is produced with renewables, hydro, wind, solar, and others, then the specific generation of carbon footprint will be zero. So the CO2 emission will be net zero. So here I complete the comparison showing the huge gap between heat pumps and fossil fuel-based technologies to produce the same amount of heat, saying that for sure it is 100% reduced in case the electricity of that electrical driven heat pump is acquired from the renewable energy sources, while in case that electricity is buy from the grid, the reduction in terms of carbon footprint will be in a range from minus 80% up to minus 88% when comparing with coal. Okay, here I'll start the comparison in terms of operative costs. So it is an economical consideration about that. When talking about the fossil fuel-based boiler, the main costs for that energy are the fuel price, that is different country per country, and the carbon tax. That is something that was introduced and will be much larger in the following years as for the global trends. While with the heat pumps, the only cost will be the power price, so the electricity that you are acquiring from the grid or from renewables. Here another chart showing the spark ratio between electricity and gas cost, so that these are also data from Eurostat from a specific range of consumption of electricity and heat. This is typical for industrial sector, showing upper side the electricity cost country per country, and the lower side the heat cost country per country. As an average in Europe, the electricity cost is in the range of 90 euro per megawatt per hour, while the heat cost in the range of 25 euro per megawatt per hour. So saying that, I will then switch to the calculation. It means that with fossil fuel based technologies, the operative cost could be 275 euro per hour to produce that 10 megawatt per hour of thermal power, while for the heat pump, depending on the COP achievable, for sure the higher it is, the lower the electricity consumption, so the lower the cost to run that heat pump, but is in the range between 90 and 180 euro per hour. It leads to a different in terms of specific cost that I highlight here, 27.5 euro per megawatt per hour in case of fossil fuel based, and 9 to 18 in case of heat pump. So there is a huge gap in terms of operative cost for the example I show here. So here are some final considerations, saying that the synergy between industry and the distributed network, so the final user and the industry that has typically high temperature heat sources, leads to high COP, so reducing the electricity consumption to run the heat pump in a specific way. The second is that the heat pump technology, in terms of operational cost, leads to lower operational cost when the ratio between COP and the boiler efficiency, so the alternative boiler efficiency, is higher than that spark ratio that is defined as the ratio between electricity price and heat price. Very important, since that spark ratio, as I showed, due to the global trends, is going to be lower. So increasing the number of cases where the COP are the heat pumps technology is particularly suitable and better in terms not only of carbon reduction but operational cost compared with the traditional technologies to produce heat. The third point, also important, is that typically heat pumps have higher capex compared with common technologies, but it is little influencing the leverage cost of it during 20 years of expected lifetime of that heat pumps. Then last point is that the global trends, as I was saying in the introduction, are leading to have heat pump technology more and more profitable, since the electricity price is reducing, the heat cost with traditional fossil fuel technology is increasing due to higher cost of fossil fuel and the introduction of that carbon tax that is increasing year after year, so that it will lead to have the heat pumps installed more and more in the industrial, but not only market. So this is my personal view about what a bright future I see for the heat pump. And I will have here my contacts, so I will be happy to be contacted from you, and then to deeper analyze specific case.
Thank you so much, Andrea.
Thank you.
And I think you have also received some questions via the chat. I would ask if you have a question, to include panelists and attendees, so the attendees can also see your questions, because maybe they would like to, I don't know, create synergies around that question. Thank you again, Andrea. And again, there's a Q&A at the end as well, but whenever you have a question, just put it in the chat for panelists and attendees. And now moving to David. Hopefully you have control of the presentation. David? Okay, if we could switch to Jonathan then. It might be a technical issue that the internet just went down for David. So.
Sorry. Okay, sorry. Do you hear me now?
Oh, okay. So he is back. Hello, David.
I'm sorry. I didn't have control of my video and audio. All right, sorry. So my name is David Bourguignon. I'm project manager of the Interreg Channel, French Channel England project, Sun People. It's a project that is going to be releasing all of its results end of July. So we are more or less wrapping up everything. And so what I'm going to show you is more a glimpse of what we are currently doing than the final results. So please keep in touch, and we'll send you everything in a few months. I will give you my contact details at the end of the presentation. So this project basically is a very small project in comparison of most of European projects. It's built around 4 partners, 2 in France, a local energy agency and a small medium enterprise, and 2 in Great Britain, a local authority, Plymouth, and a local cooperative company developing renewable solutions. We have been funded under a small project grant by this Interreg program for 2 years. So it's quite a startup mindset, if I might say, in comparison with other kind of endeavors. And we've been focusing on heat energy services. So it's a very much the topic of this conference today. But our angle is to consider that from the technologies of, let's say, new solar and heat pumps. And I will be explaining a bit better what does it mean. The challenge for us is, of course, to move the entire ecosystem with us, because it's not a single solution. It's a common endeavor. I will not explain in detail what are energy services, but basically to recap is we have to switch from a mindset that comes back from the 19th century, where we are selling goods like kilowatt hours of electricity, of cubic meters of gas, and so on, to a mindset of service where the goal is really to satisfy the customer expectations and only this, and on any mean that achieves that goal is good. And for the customer, it's a better deal in a way, because it will be achieving really the goal is aiming at, and not some intermediate steps like the energy itself. And from a very practical perspective, when you look at the individual housing, for example, this sector is very much late on let's say, energy transitions, because of the burden that the customer has, both as an investor. He has, for example, when you have to deal with, let's say, upfront costs that are very high, it's for many people very, very difficult to make that happen. And also the simple fact that people do not have the knowledge and maybe the time or ability to conduct an installation, to find the right contractors and maintenance and so on. It's really, really difficult for most of them. So energy service want to change that. And so in some people, we have been considering that from a more, let's say, information technology point of view. We think that part of the issue is also that there is no unifying understanding of what's the energy service and what are the conditions for this, for the success of this. So we have been using several software to build what we call a site data pipeline, which will be released, as I said, end of July. It's more a methodology, if you want, to help us design the right solution for the customer. So we start very traditionally from an understanding of what we call the energy scheme, which is basically what the market is currently delivering. It's not a service, it's only a scheme that will satisfy a certain number of constraints. And then we consider that as the input to the parameter of a service. So in the very end, the customer has only in front of him or her a simple bill where the service is only somehow billed every month in a very straightforward way to achieve a certain number of indicators. So if I'm a bit more practical, if you see such screen, for example, on your mobile phone, you would say, okay, for me it's quite simple. I pay 70 euros per month. I have reduced my consumption of energy of 83% and so on. So it's a very, we have to simplify the life of the customer and really provide them with the right answer at the right level of information. And of course, as I said, it's an information issue too, because to achieve things like that, you have to exchange data on a large scale. And we think our endeavor, in fact, very well fits into a larger European endeavor called Gaia X. It's about federated data infrastructure. It's about making different software and different components work together in a better way. And it's not only about computers and data, it's really about people. It's really about making organizations work together, about stakeholders cooperating, because an energy service is very rarely the product of a single company. It's in general a series of stakeholders that really have to cooperate, and that's where the complexity lies. And we think by addressing, by using such technologies or data exchange, we could simplify that. And so to conclude, the goal of the local authorities, so I mentioned Plymouth, but there is also Lorient. So this is the place where Aloen is. And we have a very high challenge of decarbonization of individual housing. We have lots of houses with oil boilers. We have to remove them. We have to replace them with solar and heat pumps combinations. And this is within the next 10 years. So it's a very complex challenge. So we think this kind of approach will help us. Thanks a lot for your attention. You have my contacts, and if you want to provide your own feedback, you have a link to an online form. Thanks a lot. Open to questions, of course.
Thank you, David. And coming up is Jonathan and Dan. Dan, you will have control of the mouse, so you can change the slides. Thank you so much again, David. And the floor is yours, Jonathan and Dan, the virtual floor and the virtual microphone.
Thank you, Dan. Thank you, David. Yeah, I'm from Plymouth City Council in the southwest of England. We're a city, not a massive city, but a small city by the sea. Dan, would you mind moving on to the next slide, please? Yeah. And we're very pleased to be working with David and other organisations through this European project. It's really kind of helping us to expand our understanding of heat pumps in particular, but also other technologies in combination with heat pumps. And similar to many municipalities everywhere, many have declared a climate emergency. So we're one of those local authorities, and we realise that we can't do things alone. We have to. Our commitments, our targets are very challenging, but I think it's important to sort of think about the role of local authorities in this space in trying to develop solutions with other organisations, particularly locally. So through the climate emergency, we have a partnership with other organisations, and we're not only trying to decarbonise our own buildings, but also work with other actors to explore other solutions. We are looking at business models around district energy, but one of the biggest challenges in the UK, we don't have a huge percentage of connected buildings to district energy at the moment. That needs to increase massively, but is the existing housing stock and the existing commercial other buildings. Retrofit is the biggest challenge. And just to build on what David was saying is, we've got lots of different building types, lots of different building owners, all who have to be educated, understand the role of heat pumps. In the UK, the Climate Change Commission published a report just before Christmas in December, emphasising the role of heat pumps the key role of heat pumps in terms of decarbonising the UK, and that's no similar to any other European country. And some of the challenges are that, yes, for building owners, David said, for building owners to all be educated to understand the role of heat pumps and the best technical fit, when the market itself is also rapidly expanding and developing in this space, which is great, particularly around retrofit and high temperature heat pumps as well, is quite a challenge. And the other challenge in the UK is the high capital cost. So we've been doing some working with PEC Plymouth Energy Community, who are a local actor, community energy organisation, to explore different disruptive ways of approaching it. So not just understanding technically what is the best solution for different building types, but also how can we overcome those barriers. So I'll hand over to Dan now to perhaps explain the role of community energy.
Right. Thank you very much, John. And yeah, really building upon that topic that David and John have mentioned around collaboration, and particularly the role of community energy groups in this delivery of decarbonising heat. And potentially that playing that role between the likes of local authorities and also industry as well, both in terms of the supply chain industries and also those who need to decarbonise their heating. Community energy, they're often non-profits, and certainly in Plymouth Energy Community's case, we're a non-profit. We're there to benefit the community. And by that, our overall aims are to reduce carbon emissions, heating of which is obviously a massive factor. We want to reduce energy bills for local people, and we want to tackle climate change. So there's some big aims there, and people often look at community energy and think, oh, it's kind of small, volunteer-led. But actually, there are a lot of community energy groups in the UK. There's around 300 or so in England alone, and they have a very good track record of delivery. If you take solar, for example, and electricity, they've delivered around 200 megawatts of solar across the UK. And in Plymouth alone, Plymouth Energy Community owns about 20% of the city's renewable energy generation, which is that's quite a lot. And if you look at that track record in delivering electricity projects, and you compare that to heat, well, it's much less. And I think that sort of goes to other businesses as well. And while there's 200 megawatts of renewable electricity owned by community groups, there's only 2.1 megawatts of renewable heat. So this should be looked at as an opportunity. We need to decarbonize heat. There's a proven track record there, and there is a big gap to fill. So community energy groups can play a role in that. And in terms of that collaboration, what is the role that community energy can play, and where can they fit into your business models in particular? Well, what they are good at is they know the community very well. So if we're talking about retrofit, as John mentioned, retrofit of residential, or looking at SMEs, so maybe the smaller scale projects in particular, then they are very good at getting through the door and talking to these people in a way that is friendly, they understand, and they trust. So Plymouth Energy Community is an independent organisation, so we can offer independent advice. We're not coming in there with a big sales pitch, and we can help people to ask the right questions of installers, and we can help people identify the right business model for them, and we can basically give them confidence in their decision to decarbonize heat, because it is a part of the reason it lags behind that of electricity is it is slightly more complicated, and we can play a role. We can play that role in community energy. The other area we can sort of work on in that collaboration is, well, if there probably does need to be a slight skilling up of community energy groups, but we can start to develop business models, and we can work in that innovation space. We don't need, as community energy groups in some respects, as good a commercial model as a business might. Our IRR, for example, does not have to be as high because we're a non-profit. So as long as we recoup money, we're not losing money, and we are delivering those carbon benefits, then there is a role to play there, and we'd be happy to do that. It ticks off those main aims I mentioned earlier. I think David covered very well what is heat as a service. So I'll look at very much sort of why heat as a service and what is the role that community energy groups can play in that. Well, one of the barriers mentioned earlier by everyone, in fact, was around the cost, the capital cost. Well, heat as a service, there's a potential for community energy groups to fund that cost through the likes of community share offers. They've done that before for solar projects, where they come in, they own the solar PV, they operate and maintain it for its lifetime. And that basically takes off a big burden from the homeowner or business owner, in that they don't have to find that CapEx or that OpEx for that period. They just have to pay their energy bill month on month. So that's a big barrier to overcome. The other barrier I mentioned earlier is around that education piece and awareness of, why are we doing this and what are my options? And through the Sun People project, we're very much trying to tackle those issues, and we're developing a sort of portfolio of resources for community energy groups, and indeed for businesses and ESCOs to work with those customers. And those include sort of a relatively simple guide on what questions to ask an installer, what things should I be considering when I'm decarbonising my heating. And while this may sound so very simple to people on the call, these are massive issues. I imagine if you ask the average person, the average homeowner, is your house suitable for a heat pump? They wouldn't really know where to start. You know, I don't know how efficient it is, or maybe I've got some idea, but I'm not that sure. Do I need an air source heat pump, a ground source heat pump? Is it more efficient with solar PV on the roof? All things which have been looked at through the Sun People project. So we're providing that guide. We're looking at some legal documentation, which we've developed. So some templates around leases, operations and maintenance agreements, heat supply agreements that we can provide to organizations who can then roll out this heat as a service model. And they are templates and they can be built upon. And we're not saying they're perfect yet, but it gives a very strong foundation to this business model and business case. And then finally, we're also providing resource around a financial model. And again, this is it's a good financial model. It's robust and it provides a good foundation. You know, people pay for their heat on a monthly, quarterly, annual basis, etc., as that service. But we can build upon that as well and incorporate things such as carbon costs. Potentially looking at comfort as a service, which is a model that's been looked at certainly in Europe and increasingly in the UK. So we really want to provide that foundation through this project, which we can build upon, and we can work collaboratively with other organisations and the supply chain to roll this out, well, to roll out decarbonisation of heat on a much greater scale. So I think that's definitely my time up, but thank you very much. Cheers, Dan.
Thank you so much, Jonathan and Dan. And I'm sure that's great, to be honest. And personally, I would like to learn more about this. And hopefully we have a little bit of time in the Q&A so we can talk a little bit more about this, especially how you started this, how a model of how you're starting these groups and more information. Maybe we will have you for another event to talk about this, because this is great, actually. Thank you again and welcome, Thomas. Hopefully you have control of the presentation.
Well, not yet. I do have control over microphone and video. But yeah, now it's coming.
Okay, so the floor and microphone is yours.
So thank you, Dan, for putting the agenda the way you've put it, because the former speakers have already hinted on the importance of decarbonization and the importance of local energy communities. So I can add on this what else batteries can do, heat pumps can do, excuse me. They can replace batteries, they can take the same function which otherwise you would need batteries for. And of course, that's a very strong business case, and I'm going to tell you more about it in a second. Now my mirrors have disappeared. We cannot. Now it's there again. Let me just check. Okay. So this is a community in the south of Germany on Lake Constance, and they've already started 15 years ago to find ways to decarbonize their community. And if you're interested, there will be a link where you can see more of the project. And what we are doing there is a real-world demonstration of a novel technology to use heat pumps as virtual batteries. And I'll tell you more about this in a moment. For some reason, here we are. Okay, this is what it looks like. It's a redeveloped area where 22 apartments in 12 semi-detached houses at the top have been built. and some flats in the southern part. They are built to very high insulation standards. They have, as usual in Germany, PV rooftop pumps, roughly 80 kilowatts. They have 12 heat pumps, so the semi-detached houses are provided with hot water and heating with heat pumps from groundwater. And there will be gas, of course. There will be a CHP in green providing heat for the remaining flats. In the garage, there will be up to 24 electric vehicles. We also might have batteries in the individual houses to optimize self-consumption per household, not per community. And also there will be flexible household appliances like washing machines, dishwashers that shift their operation, actually consume energy when it's available. Now, all this must be coordinated, and that's the challenge. How do you coordinate these roughly 100 flexible actors to cooperate efficiently? And cooperating efficiently means that you actually consume energy when it is available. So at the left-hand side, you see a winter scenario of 2 days. You have at the top the energy exchange, electricity exchange with the grid. Below you have the production, local production of PV. So you see two very small blue parts. That's the PV. So we don't have a lot of sun in winter. You have the CHP running quite frequently. And at the bottom you see the operating time of the heat pumps and the aggregated consumption of the heat pumps. So they're running quite frequently. So they actually operate until they have filled a buffer, and then they wait until the buffer is empty, and then they start again. So that's very traditional. Now, what we do is we use the exchange of the energy with the grid as a price signal. So we assume when we're exporting energy, we have too much, and therefore it should be very cheap. And when we're importing energy, it should be scarce and therefore very expensive. And we give this price signal to the heat pumps and to the CHP and have them optimize their behavior. And what you will see is that the heat pumps shift their operation times, they operate differently. Also, you see the CHP shift their operation time. And at the top, you see that the exchange with the grid is minimized rather than exporting at some time and importing at other times. The autarky of the system is increased. So the CHP only runs for self-supply. It adapts to the power need with the grid. And the heat pumps also smoothen the demand. You see a very irregular pattern of the heat pumps operation, but if you look at what happens at the grid, it makes it very smooth. Now, the grid operator likes it. We can do that in spring. I'm not going into much detail on the discussion of that. You see a much higher production of PV. You still need some heat pumps. Again, you see how they adapt to the time when PV is available. You increase self-consumption, and you see indicated what household appliances could be doing by actually shifting the remaining energy consumption of the late evening to the early morning. There's another one in summer. I'm not going into much detail to not waste time. You can look it up in the proceedings. What I want to show you is the result it has, the impact it has on the whole community, whereas before, the self-consumption rate of the community in green here, at the left-hand side was 50%, so 50% of the energy produced was consumed internally. It rises by roughly a third to 63 to 66%. Just by shifting operation of heat pump and CHP and using the water tank as a virtual battery without any capex. And the financial effect here at the left, because we increase the self-consumption rate from 50% to 63%, that's an additional margin of 1.5 cents because there's less energy you have to sell to the grid at a low price and buy back at a high price. And the more you do that, the higher the margin. We and for 80% self-consumption rate, which would add up to 4 cents per kilowatt hour additional margin. That, as I said, is not yet including any batteries. Batteries would increase it further, but it would also add of cost to that. Now, how do you convert an ordinary heat pump to a virtual battery? Well, this is a typical control that you have for a heat pump. You have a thermal buffer, you have some curves on ambient temperature and the behavior of your heat pump. And the only thing you have to do is to do one more thing. You have to tell it a price signal, which is what we have derived from the grid point. We call it balance indicator. So that's an add-on software. And in fact, the manufacturer of heat pumps will include this in his next generation. Now, difference to any other of the proposed technologies, you don't need data to do this. You don't need to disclose any private data. So you solve some of the problems that complex systems have. Now, this is a heat pump. So manufacturer is from Austria. And it just shows how you change the behavior. You just add an algorithm. And whereas before you had a different consumption pattern, you adapted the availability. So the technology behind this is a new one, which we have developed in the last years. It's a local energy market. This is also part of the considerations of the European Commission to have dynamic tariffs. So when you have an imbalance in your community, when your price is not correct, then obviously the result is that you produce too much, or you produce too little, or you consume too much or too little. If you have an imbalance, you see it at the export of the energy from the community. And you can determine from this single information how to correct your local price, and that's what we are doing. I'm not going into much detail of this slide because it's it's another discussion, but it has a lot of benefits because you can easily use flexibility of heat pumps, electric vehicles, household items. You don't have to put in a bid, you just react to a price. You don't have to limit yourselves to 15 minutes or 1 hour product times. You just switch on your heat pump or your CHP or the charging of your car when the price is correct. And that leads to very efficient real-time pricing and use of any available flexibility. Here I just show why the use of household flexibility is an extension of this. So heat pumps are a good start. This is a typical consumption profile in Europe of dishwashers, washing machines, and the like today. And you see at the left-hand side that it doesn't fit renewable energy availability. So if you changed operation times, you can see that you can use more renewable energy. You can use your dishwasher as a virtual battery without any capex, just by intelligence. So what you have to do, of course, is that your appliances have to receive a price signal. They have to be equipped with an algorithm, and that's what we are implementing with one of the project partners in our demo project. So the two options you have, either you have a battery that shifts the energy from the time it's produced to the time when it's consumed, or you have an appliance that shifts its operation in the other direction, and there is a huge price differential between the two. So a typical washing process would be a 1 kilowatt-hour battery. So obviously, there can be many more applications to this, which we are currently exploring, like non-residential applications in businesses or industrial environments. We only used it for cooling because in Germany, so far, we don't need a lot of cooling of residential buildings in summer. It's growing. But obviously, the same principle can be applied for heat pumps or compressors used in cooling applications. Local district heating, of course, is the same. And we think in all cases, heating and cooling will be a pilot application because of its huge value and existing infrastructure, and the others will follow. That's why I'm very happy that we have a presentation here at EHPA. one last example on a larger installation. This is a small community of some 15,000 inhabitants, which already today is energy positive. So they already produce double as much renewable energy than they consume. Still, because it's not time adapted, they have to import some part of their energy from the high voltage grid and have to pay grid fees for that. So what they want to do is shift their operation of the production and consumption as much as they can and avoid this cost, which would add up to some 4 cents per kilowatt hour grid fees for all the inhabitants of this community. So thanks, this is my contact data, and I'm looking forward to your questions and the discussion. Thank you.
Thank you so much, Thomas. And a lot of discussions going on in the chat. Moving to the last presentation of today's online session and giving the floor to Mark Howard. Hopefully Mark has control of the mouse.
Thank you, Dan. I do. You gave me control just before I switched my video on. So.
Yes, please. Good. Virtual floor is yours. You can put the camera on. I'm not sure if it's on already.
I can't. That option has disappeared when you gave me control. I don't. Aha. There we go. Okay. Good. Thank you, Dan. Good morning, everyone. Great. Thank you. Well, I'm going to speak briefly about a paper that we recently published looking at the opportunities around a sort of utility-based approach to ground source heat pumps. So I'm going to talk through some slides on that. Briefly, first, I'll give you a bit of an introduction as to who we are. So Regen is a not-for-profit based in the southwest of England. We're a small team of about 30, and we're an independent mission-led organisation. So all of our work is focused around accelerating the transition to net zero and helping the energy system do that. So we provide a range of services. We do advisory work. We get involved in a lot of innovation projects. And we also have a membership, which is a vital link for us into industry to sort of bring together our innovation and future-looking pieces and ground it in the sort of realities of running a business day to day. So that's a bit of a background about us. The context for this paper is that we have, excitingly, we've got increasing ambition in the UK to decarbonise. On top of our net zero targets, we had the Energy White Paper at the end of 2020, which set out an ambition to increase the installation of heat pumps in the UK from the current levels of about 30,000 per year to 600,000 per year by 2028, which is a very steep increase. And that ambition has been probably steepened by the more recent commitment to an even earlier reduction in our decarbonisation goals announced in the last couple of weeks. Alongside this ambition to install more heat pumps, the white paper identified that we need to electrify heating buildings in a way that reduces additional stress on the grid and additional generation capacity needed. So we need to do that in the most efficient way possible. How we heat our homes at the moment in the UK is predominantly with fossil gas, and there's a small population of heat pumps. And in all future scenarios that we look at, we get involved a lot in working alongside the National Grid Future Energy scenarios, producing sort of more regionalised pictures. But the National Grid Future Energy scenarios looking out to 2050, all of the net zero scenarios involve a lot of heat pumps. So you can see here, even in a high hydrogen scenario out to 2050, we'd be looking at increasing the number of heat pumps in the UK from just under 200,000 to over 8 million. So in any of those scenarios, we're going to have a large increase in the number of heat pumps we have in the UK. And our paper was seeking to understand whether there was a role for a greater proportion of ground source heat pumps in this mix in the future. So historically, we have had a relatively low market penetration of heat pumps in the UK, about 10%, which is lower than the European average. And this low percentage is often reflected in future scenario modelling. And it's something I'm aware of from my background in the installation side of the industry, design and installation for domestic low carbon heating, is that many projects start as a ground source heat pump project, and unfortunately often face a number of barriers on the way and get changed before actual delivery. So we were seeking to understand whether there's a new business model or a new approach that could help unlock the market for ground source heat pumps. As we know that ground source heat pumps typically offer a lower peak demand on the network and a lower annual demand. So moving forward, as we electrify more heat and more transport, ground source heat pumps offer the potential to reduce that, that winter peak or that daily peak and reduce annual need for generation. The traditional model of a householder installing their own ground array rules out a ground source heat pump for about half of the homes in the UK. So about half of the homes are flats or terraced houses with little or no outdoor space that they privately own, in which they could install a ground array. So the potential to share a ground array, so installed in a common piece of land and then connected to multiple buildings, would unlock the potential to decarbonise using ground source heat pumps in about half of the homes in England. So there's some interesting potential there. And that's something we were looking to understand with this model. Another barrier is capital, which is something I'll talk about in a minute, and some of my previous presenters have talked about. But moving forward, we were looking to build a model of sort of an indicative future scenario where if we had a high proportion of heat pumps of largely replacing gas boilers in the UK, and if we could unlock the sort of business model that made ground source heat pumps work and as straightforward as an air source heat pump, whether we could, what sort of proportion of deployment we might see and what impacts that might have. So we built a model looking at how many sort of ground source heat pumps we thought could be deployed in this sort of high electrification future where ground source heat pumps and air source heat pumps are on a par. And we came up with this data. There's a more detailed explanation of it in our paper, which you can download from the website. But yeah, we built this sort of future scenario where we had a high ground source heat pump scenario as well as a high air source heat pump scenario to model. What we found was really interesting looking at the impact that could have on the grid, is that our illustrative modeling suggested there could be a gigawatt scale difference on a peak winter day between a high air source heat pump scenario and a high ground source heat pump scenario. So confirming the indication or the expectation that ground source heat pumps could significantly contribute to reducing peak demand in a high electrification future. So one of the really interesting things was that this model, I mean, it's an indicative model, so it's high level, it's non-spatial, and there's a lot of further work that could be done there. But what we found really interesting was that there is, using modest assumptions, there's about a 3 gigawatt opportunity on a peak day, which is about the scale of a large nuclear power plant. So there's quite a lot of significant opportunity there. And what we found interesting was that the model is very sensitive to the assumptions that you put in. So the assumptions about spatial distribution of temperatures on that peak day, how heat pumps are installed and size and their performance in that peak period. The sort of sensitivity around that was quite significant and could lead to this gigawatt opportunity sort of expanding up to maybe 10 gigawatts if we put some very conservative assumptions in, or shrinking down if we were more generous in other scenarios. So we think that this is a really interesting area that needs to be understood further. And that was one of the conclusions of our paper, was that sort of some further work and modelling should be done in this area, because we think it's quite an exciting opportunity, but one that needs to be understood a little bit better. So talking back a little bit to the sort of capital costs, so bringing these two things into line, so we've got that big opportunity for reducing network impact there. An obvious issue at the moment that we're all aware of is that fossil fuel appliances are a lot cheaper than heat pump appliances. Part of this, in the UK at least, is that we have a really highly developed market and supply chain for gas boilers in the UK. So 1.7 million gas boilers are installed annually in the UK, domestic ones. And that's against the current level of about 30,000. And likewise, they're supported, those sort of gas boiler installation, gas boiler manufacturers are supported by about 130,000 gas engineers who are installing their product and marketing their product, as opposed to about 1,000 heat pump engineers that we have at the moment. So within that market for heat pumps, there's huge scope for cost reductions as it grows. And we made an attempt to, for our paper to sort of model some indications of where this market might go. And we found that with market scale, cost reductions in manufacturing and installation, as well as cost of sale, could certainly bring heat pump prices in line with one another, so that an air source and a ground source heat pump could become in line with each other. So as the ground source heat pump market grows, but we did find that even with that, it's unlikely that the capex could come down to the same as a high carbon heating appliance, and so there's probably some policy and regulation movement that needs to go there to help further incentivize uptake of heat pumps. So one thing that I think some of my former speakers have mentioned, and is I think increasingly being discussed at the moment, is this issue of the sort of spark gap between gas and electricity. And we've looked at this a little bit in the UK and how those two costs of gas and electricity break down at the moment. Largely the cost of electricity in the UK is pushed up at the moment by bearing a huge amount of the environmental levies that we put on. That made sense a decade ago when electricity was equivalent in the UK to about half a kilo of carbon for every kilowatt hour used. Now I think the most recent figure is that's come down to about 200 grams, 220 grams per kilowatt hour, which is now in line with gas. But despite gas and electricity currently having a similar carbon impact, 20% of a domestic electricity bill is environmental levies, and only 1.6% of a gas bill is environmental levies. It's very disproportionate, and this disincentivizes people to take up heat pumps and other forms of electric heating. So one thing that we looked at was whether a shift of these levies away from being just sat on electricity to a carbon levy across all heating fuels could have an impact. And we found that whilst it wouldn't dramatically change the situation, it would push things in the right direction and be a starting point to be a technology agnostic approach to decarbonising our heat. So all of these pieces, in many ways, we brought up more questions than answers in our paper, which was something that we expected. We were hoping to bring this discussion to the fore and to the attention of policymakers to get some more work looking at this potential solution to help meet our goals and ambitions outlined in my first slide of increasing heat pump installations and doing it in the most efficient way possible. The indications are that there'll be quite an appealing consumer offer with a shared ground array ground source heat pump. So our modelling suggests that your lifetime costs, if you had a ground array connection like a standing charge for gas, could bring an air source heat pump and ground source heat pump cost down to be about the same capital cost and about the same lifetime cost. So for a consumer, that would mean that they could then choose the most appropriate type of heat pump to decarbonise their building. So that unlocks a lot of potential there. We've seen this business model working with the support of the domestic renewable heat incentive, or the non-domestic renewable heat incentive, sorry, in the UK, which is now closed. So there's a bit of an absence of support there at the moment. There's potential that new standards for new build homes could drive a bit of increase in this sector. And there's obviously a strong opportunity in urban areas to complement or act as an alternative to district heat networks. But support is needed for the development of this sector and for the business models for this to work. So whilst I don't have a solution there, I hope that our paper demonstrates that there is an opportunity around shared ground source heat pumps for their ability to contribute to helping and decarbonise our buildings. And we need to keep on sort of picking away at this problem to understand it and find some solutions that could help this contribute to the sort of patchwork of technologies that will help us decarbonise our buildings and move away from fossil fuels. I think I've rattled through my slides there. If there's any questions, please put them in the chat or do contact me. The full paper is available on our website if you want to download and read it, or just get in touch with me. So thank you very much for listening.
Thanks so much, Mark. And thank you to all the presenters for their presentations. I'm sorry that we went minutes over time. But I think you'll agree that those were quite interesting and useful discussions. Now for the Q&A, now I know that there's quite an active chat going on, so maybe some of the questions you had in mind you already posted there. Starting with, I looked at the presentations before, so I have some questions of my own, and I would start with Mark because he was the last one to present. The question for you, Mark, is I saw that your paper has identified a lot, like you closed the presentation saying, has identified a number of questions and data gaps. What for further work would you like to see that follows on from this, from the work that you've already done with these papers and the work that Regen is doing?
Yeah, thanks, Dan. So I think one of the biggest questions that came away from our work was understanding that network impact and understanding the assumptions that all the different stakeholders are making about the impact of the electrification of heat on our networks. And one of the things that we became clear was that different stakeholders are making very different assumptions about the impact or benefits of the different technologies on the network. So you might speak to one network operator and they'll make one set of assumptions, or a different manufacturer might make a different set of assumptions. A different government department might have one set of assumptions and the other. And without these sort of this common viewpoint on how does a heat pump behave at the time when we're really interested in it, so on a peak winter day, something like that. Without that commonality between all those assumptions, we're often talking at odds and we're not going to get to a sensible solution, or we might have regional disparities in what does and doesn't make sense because of these different assumptions made. So one of the things that we would really like to see is a greater level of sort of data sharing between industry and government and between networks to understand how these appliances behave, get some commonality of agreement on how we can plan our future energy systems based on these sort of common understandings of behavior and performance on these times. That was, probably one of the biggest things that came out of it for me. A number of other things that are highlighted in the paper. That was a particularly interesting one from my perspective.
And you talk about data sharing as a key barrier, so the data sharing between stakeholders. Any other key barriers that you found that your model is seeing and that influences an increase in uptake in the UK of heat pumps?
So I think an issue certainly in the UK is that the policy environment changes on a regular basis. And so for the industry to deliver 600,000 heat pump installations a year, I mean, in many ways that's actually a great sort of milestone to look to now that we haven't had for a long time. But often the policy changes quite regularly, and that makes it very difficult for an industry to grow and develop and invest in its products. So the ability to deliver better quality products that are easier to install, easier for consumers to understand and use, it's all there and it can all be done, but it needs market scale. And manufacturers and installers can't invest in a bigger market if it's not there. And clearly it needs long-term policy intent to support the growth of that market from being something that's much smaller than the gas boiler market at the moment to something that needs to, likely match or overtake it. So long-term policy intent is something really important, I think, in helping deliver these improvements that we know can be delivered.
Yep. And this brings the question for Thomas. Again, very, very detailed presentation and a very useful and efficient way of using heat pumps. And that is, how do you see this this virtual battery being scaled? How do you scale this concept up?
Well, thanks for your question. So the first way of scaling is that it's completely aligned with European Commission initiatives like local energy communities and the introduction of dynamic tariffs. So as you introduce them, you automatically remove the barriers that have existed. And the second part to the question would be that you start with heat, which is typically an area which is more considered as infrastructure of the house. So the inhabitants are normally not so interested. So if a constructor integrates it, they will accept it. That's what we've done in our community. And then you extend it to all the other flexibilities that you have. We see a huge boom in electric vehicles. So an electric vehicle typically drives 5% of its lifetime. And if you need another 5% for recharging it, you have 90% of the time when it's stationary, it could be charged, but it's flexible. So that's the flexible, so it's huge. So we see heating, cooling, and electric vehicles as the kind of pilot applications, depending on the country. And then you have many others that will follow.
Exactly, and it's especially now with the rollout of EVs that is gathering pace, and semi-trucks and electrification of transport in general. So you will have more and more resources in that, because they have to think about how they are when the car is there. As you said, it's being used a little bit of
we start our first project
afterwards. Yeah.
We start our first project with the university campus, where they put a solar panel over the parking lot. And obviously, they use the same technology to charge the cars. And one car may be staying there for 2 hours and will accept a high price. Another car will be staying there for 10 hours. So it'll negotiate for a cheaper price and wait. And that way, you can actually use more energy of the PV than you could have otherwise.
Yeah.
So it's really taking off.
Yeah, it's really taking off. That's a very good remark. Thank you, Thomas. A question for Jonathan, and probably especially for Dan. When I saw the presentation, was how do you start a community energy group? Because you said about all the advantages that it has, but I'm just curious, how did you start it? Does it take a long time? Does it take a lot of resources? Did you get support from the government, the project? How did you do it?
Dan, shall I start and you carry on? I suppose in terms of Plymouth Energy Communities example, it was given came out of the city council originally, but the city council basically handed the reins over to the community at a very early stage. It just wanted to establish there was the business case for this sort of activity. So there was a bit of leadership from the council, but quite quickly, within 1 or 2 months, it put out an expression of interest to founder members. We got 50 founder members straight away, and we set up steering groups, and then they took the reins, and then we got them to elect directors and to open up the membership even more. So in other cases, community energy groups come purely from community roots, from a number of people wanting to make changes, disrupt the existing business models, see more decarbonisation projects. Dan, anything you want to add?
I think the main thing I'd add to that is that, there's a lot of different kinds of community organisations, community energy groups, and there's a lot of variation in what they deliver. They don't all deliver large infrastructure projects. Some deliver just energy advice, for example. They've all got a role probably to play in this. The other thing I'd add is, I guess we're quite lucky in the Southwest in that, Mark's on the line, but Regen provide a lot of support for community energy groups. So they provided some of that expert knowledge and helped set up some of those groups and help them to develop projects. So they kind of provided that sort of independent consultancy advice. And while there is a membership to Regen, it's pretty low cost, and it's for what the support they provide. So I think having an organisation like that's independent, non-profit, and is looking out for the communities and helping them with some of those technical aspects is very important in their development.
Indeed, and we all know that, and this comes up all the time, that we need more stakeholder involvement. We need them to know about heat pumps, for example, or they need to know about the efficiency compared to boilers and so on. So congratulations on getting what seems to be a lot of stakeholder involvement and a lot of, let's say, will to make the change. Like you said, people that just want to make a change. So that sounds great.
Yeah, Dan, if I could just add one thing, I think the other thing about a lot of these community energy organisations is that basically the investors become members too. It's totally democratic. However much you invest, and there are limits with some of the community organisations, they all have one vote. So extremely democratic. It might be £50, it might be several £1,000s, but it's another way of getting local investment into these projects, as well as other forms of investment.
Indeed. I mean, we operate on the same principle. So let's keep in touch. I think that, well, personally, I would like to know more about this, and I'm sure we can craft a special event on this, on stakeholder participation. David, for you, I was thinking that what is currently missing for realizing your vision of reference simulation platforms for systemic change? So what is missing? What barriers are you facing?
So the energy service approach will require lots of data from manufacturers, from customers, from all stakeholders to be successful, because it's true that it's a bit more complex than the traditional market, but IT could help us achieving this. I think the incentive at the European level to create sector by sector protocols that allow for a better exchange of data. So this Gaia-X initiative I mentioned is a great step forward, but it will require a lot of work. And to be very practical, in some people, we have started what we called an ontology, a description of what is needed to exchange data between the several steps in the design, so the energy scheme and the energy service, and then sum it up in the dashboard. It's possible because we are using the Polyson Designer software, a Swiss software that is very efficient at that. But of course, it will require other manufacturers to join, and it will not happen overnight. I mean, it's a really step-by-step thing, and we would like to start a kind of a community around this, and so that's why we are open sourcing everything. And the Sun People community, I hope, will move that forward in the future. So that's the first step done. It's still
first step of many, but you are on the path. So
yes, right.
Thank you so much, David. Andrea, I was just thinking that in your example that you put with temperatures that can reach 90 degrees, is that still valid with the 120 degrees output?
Let's say yes, for sure. The COP, the efficiency, so the electrical consumption for a specific output will change according to thermodynamics laws. But yes, it is possible. In particular, as Turboden, since we have 40-year experience with that organic rankine cycle that are typically operated in a temperature level between 200 and 400 degrees, we are capable to propose a unit that can reach up to 200 degrees. It is quite new, and we hope that this will cover that high temperature segment that as of today is not exploited with other technologies.
And are you able to also provide a solution that generates steam, for example? Because you talk about very large, high temperatures here.
Yes. Let's say we take our experience and our expertise with the organic rankine cycle, where steam could be either a heat carrier for that traditional cycle, or could be also the output of the condenser, so the generation of steam. Since we already have had engineering activities over there, we have plants with that configuration, we are capable to copy-paste that concept to the heat pump. So it could be interesting since, let's say, from several market analyses, the heat pump have a huge potential within the traditional temperatures, 90 degrees, but there is a lot of heat generation needed in the range of 90 to 200 degrees. So it means that basically we aim to cover that segment in addition to the traditional temperatures in order to decarbonize more and more the heat. So electrification of heat, which is one of the keywords we have.
Great. That sounds great. And as we reach the end of our session today, and again, I saw there were a lot of questions in the chat. I would like to thank our speakers for today. Very interesting presentations, a lot of discussions that can come out of this. Just for us at EHPA, there's a lot of things that we can organize, for example, different events and the things that I've seen that the attendees are interested in, as well as just to get more information on them, as we deal with a lot of projects ourselves and a lot of stakeholders, so we can kind of put you in touch with the stakeholders that might be of relevance to you. Lastly, I would just say that, as you can see on the screen, we organize a lot of events, and we have a lot of social media and that you can find, for example, on YouTube, you can find the recordings. On our social media, you can find the different events that we're doing. We also have a lot of surveys that are going on. We also have the Heat Pump City of the Year award that if you have an interesting project, you can apply for. So all the information is just there for you to take advantage of. Then, like I was saying, there's also a lot of events that are going on. And by the way, you can scan the QR code and it will give you a page with all the links for all these social media and portals that we have on the screen. And we see the situation that we're in, the health situation, as not only a threat, but also as an opportunity to create a lot of events, to invite you, to invite interesting speakers, to have attendees participate with their questions, to make some networking possible. And although, and I would say this is probably the 8th event that we had, and it's only the beginning of May, I would say to check out the ones that are incoming. There's one where we collaborate with other main events such as the EU Green Week or EU Cities and Regions. There's also some that are going to have a matchmaking possibility to them, so you can actually go on a virtual table and meet some of the people that you would like to talk about. And there's also, of course, our forum that is coming up. A little bit different this year because you can participate either offline. Hopefully everybody will be able to participate offline at the end of September, but you can also participate online. And as I know, it's free of charge. So you're more than welcome to come to that then. And it's 1.5 days long. So a lot of stakeholders that are coming to that. Again, thank you so much for the speakers. All attendees will be able to get the will be able to get the recording as well as the presentations in the follow-up package. And now that my voice is kind of abandoning me, I wish you all a pleasant rest of the day and see you at the next events. Have a pleasant rest of the day, and thank you for attending this online session.